Another way to identify ground faults in a system where you can isolate the positive and the negative is through voltage testing. Now, we're here in the lab facility at Fluke headquarters. This is a controlled environment. We don't have any public here. I've got all my personal protective equipment on. This system is representative of a utility scale system. This is a utility scale combiner box. However, you can see we only have 3 strings worth of modules connected to this combiner box because we have a relatively limited size system. Normally there'd be strings connected to all these fuses and to the bus bar as well. So what I can do here is I can measure between the positive and the negative to get the open circuit voltage of each individual string. And here I've got 1092. Then I've got 1092 and 1093. So they're all very similar. Now, if I measure from the positive to the ground, I should get 0 because this system is isolated from everything else. But here I'm getting 794 volts. And if I test between each positive and ground, I'll still get 794 volts. And that's because they're all bussed together on the negative side. So I'm seeing voltage to ground. Now, if I take this 795 volts and divide by the open circuit voltage of this module, I get approximately 14.9 modules worth of voltage. So I have about 15 modules from the positive side to the ground fault. Now, if I measure from the negative side to the ground fault, and I'm going to switch my leads so I get a positive result. I'm going to put my positive probe on the ground, put my negative probe on the negative bus bar. I get 300, let's see, it's 297 volts. If I divide that by the open circuit voltage of the module, I get approximately 5.9. So about 6 modules from the negative to the ground fault. Now, again, the problem here is that I've got all my negatives bussed together. To figure out exactly which string has the ground fault, I need to lift those negatives. So one at a time, I would unscrew those and then test from positive to ground and negative to ground for that string. If it's 0, I know that string's good. I can re-land that string, pull the negative off from the next string, and test that one and go through until I identify the string that has the actual ground fault. Now, an easier way to do this, of course, would be to use the Fluke GFL-1500 ground fault locator, which will do this analysis for you. And then you can use that to actually locate the fault using the receiver or the current clamp. But if you don't have access to that, a voltage testing can be another way to identify the location of a ground fault approximately. And then once I use that voltage in the math calculation, I can go out into the array, figure out where my string is, figure out where those modules are, and then try to visually identify the location of the ground fault.